imagine you're giving a TED Talk, okay, and 891,000 people just so happen to walk by you giving your TED Talk. 300,000 people decide to stay and like walk into the building where you're giving your TED Talk. That is kind of what I'm here to talk about. And I'm going to use the planets in the solar system to explain. Okay. The best way I can explain gravity is that two objects have mass, and when those two objects interact with each other, their mass will dictate how much they're pulled to one another, and that's essentially their gravity. And we know gravity from like the moon landing and stuff. We also know gravity from being here on Earth. If you jump, you fall. If I were to chart that, it would look something like this. Like, foop, 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 foop. So this piece of paper, this flat 2D piece of paper is space. And anytime you add an object into space, it's going to create a bend, a ripple in space. It's also going to create time, because the amount of impact it has on the space, that's what creates time. It's created also by the amount of time it takes to get from one point to another. You have one object in a space, you've got a little bend in time. So you have the sun, which is a really big object in the solar system. It's also relatively far away, and the Earth is going to orbit the sun. And there's a few reasons that it does that. The first thing is that we have gravity between the two, so there is going to be a pull between the two objects. But the sun, being a lot bigger of an object, which is doing its own rotation around the galaxy, around space, has pulled in enough objects with enough mass that are close enough to it that they're going to create their own orbit around the sun, which is also moving around space. When I jump, I'm pulling the Earth towards me, but somewhere out here there's an asteroid belt, flying space objects that lost their ellipses and flew out of orbit, kind of like outliers. So if you have Earth orbits the sun and the moon orbits the Earth, okay, so you've got kind of like a funky triage going here. Polyamorous, but they're also monogamous. They're pretty monogamous objects. The closer and closer it gets, the more it's pulling the sun towards it as well. The further away the Earth is, and the bigger, the more dense, the more mass the sun has, the faster it's gonna pull in the Earth until it gets close enough to the sun that it's gonna spin around it and they get launched out by all the momentum. Sitting in time and space in a ripple of like this galaxy, okay? But in our solar system, everything orbits the sun. It's heliocentric. Jupiter is really big, but it's also pretty far away from the sun, so it doesn't move as quickly. It doesn't move as fast as Venus. You see how you can see that? You can see Venus. You can't see Mercury. You can't see it because the sun's too bright. You can't see it. And it does a complete circle, but from our point of view here on Earth, it does a semicircle like that. Neptune, which is the furthest planet in the solar system, and it's freaking cold on Neptune. Jupiter is way far out from the sun, but it's so big that it takes its sweet time orbiting the sun. But hopefully you got something out of this that is helpful for your life. And even more so, I'd like to know what it is that you got out of this that you find helpful for your life. And seriously though, hit the subscribe button. And that's all I have to say. So thank you so much for watching, and I will see you very soon.